Welcome to my YouTube channel Math Academy, and please subscribe my channel for more updates. And here the question number 6 says that speak the two statements. First option is, if a 5 by 5 matrix A has fewer than 5 distinct eigenvalues, then A is not diagonalizable. A has fewer than 5 distinct eigenvalues means at least 2 eigenvalues has same. Okay, so we know that all the eigenvalues are roots of the characteristic equations. So characteristic equations must be, if I take characteristic equations of A is x square, here two roots means 0 are same, and the third root is 1 and fourth root is 2 and fifth root is 4. I have take these characteristic equations of A. This will be, and we know that minimal polynomial of a matrix divides of the characteristic equations. So, and also all the eigenvalues of the A must contain minimal polynomial. So minimal polynomial is contain all the eigenvalues and which is divides the characteristic equations. So characteristic equations possibility is 2. First one is this and second one is this. And we note that theorem, if a matrix A is diagonalizable, if and only if A has distinct factors, and the first minimal polynomial says that all the roots are distinct, hence A is diagonalizable. But the second minimal polynomial says that minimal polynomial is not distinct factors, means x square has the degrees 2, hence this minimal polynomial roots are not in distinct. So second polynomial says that A is not diagonalizable, but this minimal polynomial says that A is diagonalizable, and the first option says that A is not diagonalizable, so option A is false. It may or may not be true. And option B is, eigenvector must be non-zero vectors. It will be true by the result, because if eigenvector is 0, then eigenvalue is undefined. So eigenvector must be non-zero eigenvector is true. So option B is true. Option C says that if A is similar to a diagonalizable matrix B, then A is also diagonalizable. Let's check the results. Here diagonalizable matrix B means if a invertible matrix P and D is a diagonal matrix, P is invertible matrix and D is a diagonal matrix, and it says that B is diagonalizable, and then by the definitions of the diagonalizables, B is equal to PD P inverse, which is by the definitions of the diagonalizable matrix of B. And it also says that A is similar to the diagonalizable matrix B, and by the definitions of the similar matrices, there exists invertible matrix Q such that A is equal to QB Q inverse, and the putting the value of B will get PD P inverse Q inverse, that means QP D QP inverse. So A is also diagonalizable by the definitions of diagonalizable matrix. So A is diagonalizable by the definitions of diagonalizables. So option C says that then A is also diagonalizable. So option C is also true. Option D says that similar matrices always have exactly the same number of eigenvalue. It will the results For the similar matrices, just not only eigenvalues, its eigenvalues, trace, determinants, characteristic equations are all the same for the similar matrices. So option D is true. And question number 7 says that define T is a mapping from P2, means P is a polynomial of degree at most 2, from R3 by the mapping T of P is this. Then pick out the two statements. First statement shows that T is a linear transformations. By the definitions of linear transformations, it will be easily check what will be definitions of linear. If T is a mapping from V to W, then T of Cx plus dy, Ctx plus d ty for all x y belongs to phi, and C and D are scalar. So using the definitions, it will be clearly shows that T is a linear transformation. So option A is true. Option B says that T is onto of, T is invertible. Option C and D is none. So I will find the matrix relative to the order basis of P2 with respect to R3. So the basis of P2 by the order basis is 1x x square, since 1x x square, since dimensions of P2 is 3, so there will be must be 3 bases, 1x and x square. And for the first basis, if I take P of x is equal to 1, then T of, if I take P of x is equal to 1, then T of P means 1. So T of 1 is equal to first matrices, its all the elements are 1. So it will be written in the form 1 into basis of the R3 is 1 0 0 0 1 0 plus 1 0 0 1. For the similar process, if I take P of x is equal to x, then T of x will be P of minus 1, that means minus 1, P of 0 means 0, P of 1 means 1. So in the same process, 1 0 0 plus 0 into 0 1 0 plus 1 1 0 0. If I take P of x is equal to x square, then T of x square is P of minus 1, P of minus 1, that means 1, P of 0 means 0, P of 1 means 1. So in the same process, 1 0 0 we writing in the order basis form, plus 1, sorry, it will be 0 1 0 0 1, and it will be also 0 0 1. And so the matrix of T relative to the order basis P2 with respect to R3 is matrix. We write the matrix in, we write this element in column vectors. So 1 1 1 in right in the column vector, that means 1 1 1. Second vector is minus 1 0 1. So column vectors minus 1 0 1 and 1 0 1. So 1 0 1. So if you check, determinant of A is 2, that means not is equal to 0, and option C says that T is invertible, right? Since its determinant not is equal to 0, so option C is true. Determinant of A is not is equal to 0, that means rank of T is 3, and by rank nullity theorem, nullity of A, that's mean nullity of T plus rank of T means 3 is equal to dimensions of A. So dimensions of P2 is what? 3. So nullity of T is 0. That means T is 1 1. So nullity of T0 means T is 1 1, but this option is not here. Here given T is on to check. So rank of T is 3. That means dimensions of image T, which is also R3. So this will be same. So T is on to. So option B is true. And please subscribe my channels for more tests, and tomorrow test will be linear algebra at 11 AM. I will post the question in my YouTube channel, and please subscribe my channel and share with friends for more CSR net test. Thank you.